Okay, in our first video in this series, we looked at example 1 and learned how to use trig identities. In this case, the cofunction identities, quotient identity, and a reciprocal identity in order to solve a trig equation. Now, to try another example of that, you were asked to try to solve this equation on your own. Sine of theta times cosecant of theta all divided by tangent of theta equals 1. If you didn't take time to do that on your own yet, go ahead and pause the video and try it, and then come back and check your answer with us. So for those who have finished this problem, let's go ahead and work through it together. So we want to take a look at our trig identity hexagon here and recall that sine is right here and cosecant is right here, and that the diagonals through the identity hexagon, those are reciprocal. So the reciprocal of sine is cosecant, and reciprocals multiply to equal this value in the center here, which is 1. So I can use that product identity, the sine times the cosecant equals 1, to replace that numerator with a 1, or we could show that reciprocal relationship, that the sine of theta, and then substitute out the reciprocal for cosecant, which is 1 over sine of theta, and then you'll see that the signs cancel and you're left with a 1. So either way is fine to end up with 1 over the tangent of theta equals 1. Okay, and then we can cross multiply here, and tangent of theta times 1 is tangent of theta, 1 times 1 is 1, and now we're back to a one-step trig equation like we solved in earlier units. So to get theta by itself, we're going to take the inverse of both sides. So theta is equal to the arctan, or inverse tangent, of 1. And we're going to go over to the first quadrant of the unit circle and recall that the tangent is the ratio of the sine over the cosine. So 0 divided by 1 would be 0. So the tangent at 0 is 0. And 1/2 divided by root 3 over 2 is 1 over root 3, or root 3 over 3. That would be the tangent at pi over 6. Root 2 over 2 divided by root 2 over 2 is 1. So the tangent at pi over 4 is 1, and that's what we were looking to find, was the tangent at pi over 4. So now we know that theta is equal to exactly pi over 4. That would be one of the solutions to this trig equation. Now we need to recall that all students take calculus. That was the acronym for remembering what trig functions are positive in which quadrants. So A means that all 6 sine, cosine, tangent, secant, cosecant, cotangent, all 6 are positive in quadrant 1, and we already found that quadrant 1 answer. The S means that sine and its reciprocal cosecant are positive in quadrant 2. We're looking for where tangent is positive. T in quadrant 3 reminds us that tangent and its reciprocal cotangent are positive in quadrant 3. And then the C reminds us that cosine and its reciprocal secant are positive in quadrant 4. So we already found our quadrant 1 answer, which was pi over 4 in quadrant 1. Now we know that we need another solution because tangent is also positive in quadrant 3, and half of the circle would be 4 pi over 4 radians. So to get from 0, right, this distance was pi over 4, that means to get from 4 pi over 4, the same distance, into the third quadrant, I would add pi over 4, and I'd be located at 5 pi over 4. So that is the second solution to this trig equation. Theta equals 5 pi over 4. Now we want to check those solutions in the graphing calculator like we did in example 1. So we're going to first make sure that we're in radian mode in the calculator. and then we're going to type in this original equation after we tell the calculator what we want to use for theta. And since I don't have a theta in here, I'm going to go ahead and use x. So I'm going to take pi over 4 and store that as x in the calculator. And then I'll type in that original equation with the sign of x in the numerator. And notice there is no button here for cosecant. There's only a sine, cosine, and tangent button, but I need cosecant in order to check. So that means I'm going to need to enter a reciprocal identity in here. So we're going to put in, for sine times cosecant, we'll do sine x, and then times, and cosecant's reciprocal is sine. So cosecant is equal to 1 divided by the sine of x. So we'll type that numerator in just like that. Then the denominator is the tangent, and we do have a button for tangent, so we can use it. And second, math opens up the test menu. That's where we find the equal sign. So we enter that equals, and we want it to equal 1. Now, just like we said in the last video, once we press enter, we are asking the calculator a question. We're asking it, is it true that when pi over 4 is substituted in for each of these x's in this equation, is it true that that equals 1? If it is true, the calculator will return a 1 for yes. It'll return a 0 if the answer to that question is no. So we press enter, we get back a 1, and we know that pi over 4 checks as a solution. Okay, now we're going to check 5 pi over 4. So we'll store that as our x and press enter. And now we can arrow up to grab that equation that we typed in previously so that we don't have to type it in again, and press enter, and we get another 1, and so that solution also checks. And those would be the two solutions for this trig equation over the interval 0 to 2 pi.